Okay, so we were discussing this before we were on the one break. What does this mean? VSWR is at 1.5. What does this mean? What does this mean? VSWR is at 1.5. So if we match an antenna very well with the transmission line, the VSWR we expect that should be high or low. If low, then how much low? It will be 0, it will be 1, it will be what? It will be 10, or it will be negative. For a very well matched antenna, what will be the VSWR we should expect? 2. Okay, fine. Why 2? What is VSWR? Yeah, for perfect match, 1 is a better answer. For ideal match, VSWR is 1. Okay. 2 is also okay. Look, actually, in practical case, what Niloy's answer is perfect. 1 is the ideal. If it is less than 3 dB, we take it. Or what you said, Ritika. If it is 2 or less, we take it is good. Now see what the specification is suggesting, that VSWR is less than 1.5. So what does that mean? It means that in the entire range of this 800 megahertz to 2.7 gigahertz, the manufacturer is guaranteed that the VSWR of my antenna will be within 1.5 if the characteristic impedance of my transmission line is 50 ohms. Did you get it? Did you get it? Did you get what I said? Okay. All of you agreed? What does this mean? Right? All of you? Yes, sure. That's what I wanted to say. The manufacturer is guaranteeing that. That's what I'm telling. Listen carefully. That's what I'm telling you. The manufacturer is guaranteed that within this frequency range of 800 megahertz to 2.7 gigahertz, the VSWR of our antenna will be guaranteed to be less than 1.5 if we use a transmission line whose characteristic impedance is 50 ohms. Okay. What do you mean by load impedance, Niloy? The antenna itself is a load, right? So if we have this antenna, if we have this particular antenna, then we do not have to use any external matching circuit. Within this frequency range, if we use a 50 ohm characteristic impedance line, then it will be more or less matched. That's what the manufacturer wants to say. Yes. Any questions? The antenna itself is a load impedance, right? Any questions? Anything? Got it. Okay. Anybody else? Any doubts? Anybody else? So, as an engineer, you're expected to interpret these specifications. What does the specification say? Nobody will tell you to go to the roof and fix the antenna. No. But you should be able to understand what this means. Anybody else? Any questions? Connected type. Okay. These are typical connectors. This is called SMA connector. Okay. So SMA female, it is probably this type of a thing. Yes. The connector is like this. Wait. The antenna connector is like this. That is what is meant. Okay. Next, FB ratio 118 dB. What does this mean? This is a very critical question with the Yagi. What does this mean? FB ratio is greater than 18 dB. Okay, sorry. Horizontal beam width is 38 degree, vertical beam width is 34 degree. This is more or less clear, but self-explanatory, right? Nothing to tell you. Beam width, you know, right? So this no point in spending time. Input impedance is 50 ohms. This is also understood. No point in discussing this. What does this mean? FB ratio. What is FB ratio? Started. Are you there? Yeah, yes, yes, yes. Mm, okay, FNBW or FPB, HPBW, it is not specifically mentioned actually. So I don't know. Yeah, this answer is correct. Ratio of front radiation to back radiation, right. So what is 18 dB means that front radiation lobe is 18 dB higher than the back one. Okay. So what does this mean? That the Yagi-Uda, this Yagi antenna, it gives a one very directed beam towards the director. Okay, director. That's why it is called the same. The beam is like this. Sorry, sorry. The beam is like this. It gives one concentrated beam towards the director. Okay. That is the reason why, one of the reasons why it is very popular as a TV antenna. It has a very high gain. Okay. A quiet broadband, not as broadband as the next antenna we'll discuss in the Monday. Okay. Quiet broadband and high gain. That's why it has become very popular as TV antenna. The radiation pattern is a very one beam pointing towards the director. Okay. What next? So the Yagi antenna, the main feature of an Yagi antenna is that it gives us one beam, a high gain, a narrow beam pointing towards the director. Why? Because see, there is a continuous phase increase between the elements. There is a continuous phase increase between the elements. Okay. So obviously, if you see the array lectures, that patterns to an end fire array. Okay. So Yagi-Uda is basically an end fire antenna, right? And not just any end fire antenna. The Yagi array, it is designed so that it gives one concentrated beam towards the director. There is hardly any radiation towards the reflector. Okay. So we can, all we need to do is to point our antenna toward in the direction where we expect the radiation to be coming from. Okay, or the direction where we want to radiate. Is it okay? Those who have seen Yagi antennas in that rooftop of TV antennas, ideally they should be pointed towards the direction in which the TV station is located. Okay. Now, how to design an antenna? You can put more reflectors, but that will not make much difference. However, if we keep adding directors up to a number, if we had 100 directors, that will not make much difference. But say 3, 5, 7, more the number of directors, more the gain. Okay. And we have seen in the Friis equation that if we increase the gain of the antenna, the received power is increased. Those of you who live not in the cities, maybe some 50, 60, 70 kilometers away from the big cities, they will see that they use Yagi antennas with more directors so that they have a good reception from the TV. Is it okay? Any questions? After that, in the book there are formulas, but those formulas don't help. You just what for this antenna, what is required, how it works, what is reflector, what is directors, okay, what is the length, what are the distances, what is the radiation pattern, okay. So these things are important. There is a very big derivation in Balanese which you absolutely no need to do. Don't have to do it. And that's why I'm not doing it also. Any questions? Any questions regarding this? We have, I think, 3 more and yeah, the question. Initial radiation increases, directors added. Why it doesn't increase? Okay, because it is scientifically measured. Okay, it doesn't. You can after a while you cannot, because obviously the gain of the antenna you cannot have like very more, because after that the alpha is not so much to make any difference. Okay, 5, 7, 10 is fine. After that, even you have you will see the alpha, and moreover thing is that it will not be mechanically feasible, it will be too heavy, difficult to balance. Okay. Very, what to say, a very crude answer would be because of the alpha, the values of alphas. Any other questions? See if what I have missed something or not. Moreover, you see, okay, Ravi. Moreover, you see that if you keep on adding elements, sorry, then the further elements will become much away from the feeder elements. Okay. If I keep on adding elements, the extreme end elements will be much away from the feeder element. So obviously the induced voltage current will be very low. Okay, because it is away. For induced current to induction to happen, the parasitic elements must be close to the feeder elements. If you make it too far, then there would be very less. Okay, this is another reason. Okay, large satellite antennas, what we see, they are parabolic reflector antennas. Okay, they are not Yagi. They have even higher gain. Parabolic reflector antennas, they have much even higher gain than Yagis. And second thing, Nilay, large means that don't think that larger the antenna, larger the gain. It's not always true. Larger the antenna means that the antenna is working at lower frequencies. Think in this way that dish antennas which we used to have 20-25 years ago, they were much larger than the dish antennas which we use now for this satellite TV. Why? Because now the frequency has increased a lot. Okay, previously it was 1 gigahertz, 2 gigahertz, maximum 4 gigahertz. Now it is in 15, 16 gigahertz. Okay, that is the reason the antennas have become much smaller. So larger antenna does not necessarily mean larger gain. Larger antenna means less frequency. Okay, right. So now since we have the topic of antennas, have anybody listened? Does anybody know the antenna joke? There is just one joke about antenna. Does anybody know it? It is very famous or infamous. I thought I should have told this one in the first class, but I forgot. Anyone who know the antenna joke? Yes, I will tell, but does anyone know it? Okay, it is like this. There were two antennas, okay, in the roof. So in a roof there are two antennas. So these two antennas they fall in love and get married. Okay, the marriage was ordinary, but the reception was very good. Who will explain this joke? Sorry, I couldn't get that smile. I saw a square. What does that mean? It's a bad one, bad joke. This joke was told to me by a very, very famous professor. Reception here means what? That's the question. That's the punchline of the joke. The marriage was ordinary, but the reception was very good. A very, very famous professor from USA told me this joke once. Okay, any other question or we wrap up? Acha, another thing, the group B students, do you want a revision lab class tomorrow? The group B students, do you want a revision lab class tomorrow? Reception means what exactly? The reception has two meanings. It could be marriage reception as well as it could be the what you have wrote, the radiation received by the antenna. Exactly. And if you have studied arrays, you will see that there were two antennas. Higher the antenna, better the reception. Okay, but that is a very layman thing. We have seen, right, what makes the antenna good in reception. We have seen antenna arrays that there are two antennas in an array, then it could be have a better reception by some means. We have seen those means. Okay, so group B students, do you want to have a revision lab tomorrow? Because group A students will have a lab anyway on Friday because they have an experiment left that has to be done. Group B students, do you want a lab tomorrow or not? Tell me, do you want it and do you want? Okay, the class is over, so we can stop recording. So, group B students, do you want a